Today we're going over 6.7 permutations and combinations. So the first thing we're going to look at is what a factorial is. And what a factorial is it's going to be ordering a particular set of items. So let's say, for example, we have 4 desks and we're going to order 4 students in these desks. So what we're looking at here is the order is going to matter for this. So we're looking at how many ways can I order these 4 students in these 4 desks. So I can say, okay, I have for this first desk here, I have 1, 2, 3, 4 students that I can choose from. So let's say this person sits down. Okay, then I only have 3 students to choose from. So that one will sit down. Then I'll only have 2 students to choose from. And then the last one. So this was looking at 4 students and ordering them in 4 different desks. So we call that 4 factorial. And what that's doing is you're going to be multiplying it, which means you're going to use the multiplication counting principle, or the factorial notation, which is whatever this number is, 4 factorial, you start with that number and you multiply going all the way down to 1. So if you're going to do this, you can multiply this out by hand. 4 times 3 is 12. 12 times 2 is 24. But when it gets to be big numbers, we're going to want to use the factorial on our calculator. So to use this, we are going to press in the number that we want to find the factorial of, 4. And let me make sure you can see this. And then we're going to click on Math. You're going to arrow over to Probability. And then we're going to use number 4 for the factorial. And then we will press Enter and we get 24. Okay, so that's by using the calculator. It also has it on the iPhone if you turn, or on the smartphone if you turn your phone. It has factorial and it looks just like that. Alright, so this is if we are using all of them. So we used 4 students and all 4 desks. Alright, so then this is also a type of permutation. So for a permutation, we are looking at, this has to be going in a particular order, meaning the order matters. Okay, so for example, if we're ordering the 4 students in the 4 desks, then that would be a type of permutation where we're ordering all of them. Okay, if we're looking at something where we're not using all of them, that's when we're going to use the permutation formula. So I'm going to write it as n permutations r is equal to n factorial divided by n minus r factorial. So make sure when you put this in, you subtract before you find the factorial. So let's say, for example, we're doing 10p4. So our first number is always bigger because we can't say that we have 10 students and we're ordering them into 4 desks, it would be, this is how many students we have. 4 students are going to be arranged in 10 desks. So this one always has to be bigger, the 10, or in this case your n. So we'll rate it as, they both have to be positive, so they have to be greater than 0. And then we know that r is less than or equal to n. And they can also be equal to. Okay, so we're looking at 10p4, so we'll plug that in. 10 factorial divided by 10 minus 4 factorial. So this will give us 10 factorial over 6 factorial. And if you're doing this by hand, I would suggest to write this out, 10, 9, 8, 7, 6, and then stop the numerator at whatever the denominator is, because then we'll just write this as 6 factorial divided by 6 factorial, and then these will just cancel out, and then you'll multiply 10 times 9 times 8 times 7. And that will make it easier than multiplying it all the way down instead of writing it all out. Okay, so we'll multiply that out and we get 5,040. Or if you're using your calculator, your graphing calculator, then you will put that in as 10. And then you're going to press math again. You arrow over to probability. So probability. And then there you have NPR or NCR. So we're going to press number 2 for the permutation. And then press 4 and enter. And we get 5,040. Okay. So let's look at an example of when the order would matter for permutation. So let's say we have 7 runners in a race. And the first 3 runners score points for their team. We want to know how many arrangements of first, second, and third place are possible. Okay, so we're going to set this up as a permutation because since there are 7 runners in the race and the first 3 runners are going to score, it matters what order they come in, because it will matter if I get first place or if I get second place. That's different. So I'm going to write this as 7 and then our permutation P3. So using our formula, we'll do 7 factorial over 7 minus 3 factorial. So this is 7 factorial over 4 factorial. And we can write this out as 7, 6, 5. 4 factorial is where I'm going to stop, because the 4 factorial will cancel with the 4 factorial, and then you're just multiplying out 7 times 6 times 5, and that will give us 210. Or you can plug it into your graphing calculator as 7p3, and you'll also get 210. Okay, so moving on. Now we're going to look at combinations. So for combinations, combinations. We're still looking at a selection and how many times the selection can come up. But now the order does not matter. All right. So if the order does not matter, then that's going to be called a combination. So if we're thinking of an example for a combination, we can look at something like forming a committee or a team. So if I have a math team, and I'm going to choose from all of my students, it's going to be a pretty big team. So I have 150 students about, and I want to have about my top 140 students in it. Then this doesn't matter which order that I name all of my students in. It means if I call your name, then you're on the math team. It doesn't matter if I call your name first or second or third or last, it doesn't matter. So that would be a type of combination rather than a permutation. So the formula for combination then is N, C, R, where N is still bigger than R. And this is going to be equal to N factorial over R factorial times N minus R factorial. So it's pretty similar. The R factorial is the part that we're adding on. So let's say that you have a reading list of 20 books. So you have a reading list of 20 books. And we want to know in how many ways can you choose four books to read. So the books are not related. So we have to first decide, is it a permutation or a combination? Meaning, does the order matter or does the order not matter? So since we're choosing four books and it does not matter which order we choose the books in, then it's going to be a combination. So we'll plug that in and we have 20 books in total, and we're going to use a combination here, 20C and then 4. So we get 20 factorial over 4 factorial times 20 minus 4 factorial. So this will be 20 factorial over 4 factorial times 16 factorial. And if you're multiplying it out by hand, go down to the 16, or the bigger number. 20, 19, 18, 17, 16 factorial, because 16 factorial would keep going down, over, we're going to multiply out the 4 factorial, 4, 3, 2, 1, and then I'm going to leave this 16 factorial, because the 16 factorials will cancel out, and then you'll multiply this all out here. Or if you have a graphing calculator, then we'll put that in. So we put 20, and then we press math. We arrow over to probability. We press number 3 for combination. We press number 4 because we're choosing 4 books to read. and then we press enter. And we get 4,845. So there are 4,845 different ways that you can choose 4 books out of this 20 book list. And there are so many different ways, because if you just change one of the books, then that is a different order. And this is going over permutations and combinations.